So what's the relationship between momentum and safety? Well, the problem is that a very fast change in momentum is going to result in a large force being exerted. Let's see how this works. We know that the force is equal to the change in momentum, which is the mass times the change in the velocity, divided by the time taken for this change in momentum to occur. Now, if we fix this change in momentum, then a very fast change is going to mean the change takes a very small time. But when we decrease the time taken, we increase the force, because this equation tells us that the force is inversely proportional to the time. In many circumstances, having such a large force act on something can be dangerous and can cause injury. A good example of this is a car running into a wall. We can imagine however fast the car was moving before, pretty much when it hits the wall it stops. So this could be a large change of momentum, but in a short amount of time. That means the brick wall must be exerting a very large force on the car, and this could be dangerous. In order to minimise the force acting on us, the time taken for the change in the momentum should be increased in any way possible. Cars have many features which reduce the force in the case of crash by increasing the amount of time it takes for us to stop moving. That is, increasing the time it takes for our momentum to change. The longer it takes, the less the force. One great example is the seatbelt. The seatbelt will stretch, which increases the collision time, or the time it takes for you to go from moving to not moving.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific GCSE physics and combined science videos, just click on the Snap Revise smiley face. Join me today and let's make physics at GCSE a walk in the park.